Welcome to the IM2. This is Unit 7, Chapter 7's Review Sheet Solution. Here I'm going to cover questions 9 and number 10, which are your trig and your inverse trig. Alright, so let's do this. You have to use Desmos to do this, just to let you guys know. Alright, so A, you're trying to solve for the unknown value of x. We start by drawing our person here from the point of view of the 41 degree. The 12 would be its opposite point of view. The x is your near, so that's going to be your adjacent. The two letters I have here is O and A. So what I am missing, this is going to be my O and A, so that's going to be my T, my TOA. Once I put my TOA, that allows me to set up my trig ratio. T stands for tan, so TAN. I put my angle 41 degrees. Okay, I put this in a parentheses. Tan 41. This is going to be equal to my opposite, which is 12. I'm going to now divide this by my adjacent, which is x. My goal is to get x alone. So I'm going to multiply by x. So this is just me cross multiplying. Now I get x tan 41 is equal to 12. Why? Because this goes away. This disappears. That's the reason why I just get 12 on the right hand side. I need x alone, so now I'm going to divide by tan 41. Divide by tan 41. Why do I do that? Because I should get x alone here. This tan 41 divided by tan 41 is just equal to the number 1. Any number divided by itself is just 1. This is going to be equal to 12 divided by tan 41. This is when I have to pull up Desmos. And I type into Desmos. 12 divided by tan 41. The answer is 13.8 roughly, so I can write approximately 13.8. There you go. B. We start by putting our person here on the 43 degree. We label their pieces. X is our opposite, farthest away. 26 is your hypotenuse because that is the diagonal, the longest line. Now we have the word O and we have H. Let's take a look. No, O and H. Yep. So which one is that? O and H. That is your side, opposite, and hypotenuse. So we put S here. This is going to help us set this up. So we can say sine, put the angle 43 degrees. This is going to be equal to my opposite, which is x. Divide this by my hypotenuse, which is 26. Now I'm trying to get x alone, so I'm going to multiply by 26 to both sides. You get 26 sine 43. You can now plug this into your calculator. Because do you see how x is alone? Why? Because do you see how this disappears? 26 over 26 just becomes 1. So the x is alone. Okay, that's the explanation. I pull up Desmos. I type in 26 times sine 43. That gets me 17.7. So I can say x is approximately 17.7. C. Start by drawing the guy. It's right here. X is your closest one, so it's your adjacent. 26 is the longest one, so that is the hypotenuse. You write A and H. What letter are you missing? Let's take a look at our notes. A and H, that's cosine. So I write C here. This is going to help me set up the trig ratio. Cosine, put the angle 43. This is going to be equal to adjacent, which is x, hypotenuse, which is 26. To get x alone, I have to multiply, because this right now is divide by 26, right? So I multiply by 26, multiply by 26. The reason why 26 over 26 becomes 1. So this disappears to just become 1. That's the explanation on why I multiply by 26. So on my right hand side just becomes x, because the 26 cancel each other out to make 1. This x equals to 26 times cosine 43. I can just plug this into decimals. Cosine 43. That gets me 25.9. So I can say this is roughly 26, right? Because look, it was 25.96. I rounded to just 26. Good. Let's look at letter D. Same process here. Draw the guy. Label the pieces. 6 is your closest one, so that's adjacent. X is your farthest one, that is your opposite. Write the letters. You have O and you have A. Look at our notes. O and A is TOA, so this should be T. This allows me to set up my trig ratio. T stands for tan, so I write TAN. Put the angle 37 degrees. This is going to be equal to my opposite, which is x. Divide this by my adjacent, which is 6. Now I'm going to multiply this 6 to both sides. Why? Because 6 over 6 becomes the number 1. So this disappears to be the number 1. That's the reason why I divide by 6. I'm trying to get x alone. What do I have? I have 6 times tan 37 degrees is equal to my x. I can now plug this into the calculator. In decimals, I type in 6 times tan 37 degrees. Okay, that gets me 4.5 approximately. So x is equal to 4.5. Good. So that is my x value. Let's do E. Draw the guy on the angle. Label 18. That's my opposite. X is my hypotenuse. So I have the letters O and H. I look at my notes. O and H is sine because of show. So I write S here to help me out. So I write sine of 32 degrees is equal to opposite, which is 18, divide by the hypotenuse, which is x. Multiply x to both sides. Why do I do that? It's because I'm trying to just get it by itself. Okay, so I here gets x sine 32 is equal to 18. Now I can divide, because I'm trying to get x alone, by sine 32. Divide by sine 32. I get x is equal to 18 divided by sine 32 degrees. Plug this into the calculator. (18) divided by sine 32. That is approximately 33.96, so we can say it's roughly 34. F. We start by drawing our guy. At the 48 degree, we saw that 10 is as close to the guy, so that's the adjacent. The x is the longest side, so this is the hypotenuse. We have a and we have h. Look at our notes. That's our cosine, CAH. So we write our C here. CAH tells us it's cosine. So I write cosine of 48 degrees is equal to adjacent, which is 10. Divide that by our hypotenuse, which is x. I'm trying to get x by itself, so I'm going to multiply by x to both sides. I have x cosine 48 degrees is equal to the number 10. Now I need x alone, so I divide by cosine 48. Divide by cosine 48. I get x because cosine 48 divide by cosine 48 cosine 48 divided by cosine 48. Remember, anything by itself is just equal to 1. That's why. So this becomes 10 divided by cosine 48. 10 divided by cosine 48. That gets you 14.9. Let me show you this in decimals. 10 divided by cosine 48. That gets you 14.94. So you could say this is roughly 14.9. Okay, 14.94 is, you round it down, so it becomes 14.9. Notice that all these problems that we did, okay, from number 10 were just for us to find the sides. Okay, so I can write this. We use the trig ratio to solve for the side, for the missing side of the right triangle. Right? Because it's going to be completely different when we do the next one. Right? That's what we did. Now we're going to solve for, let's look at 10. We're trying to find the angle measurement here. So again, let's start by drawing our person here. Here's the question mark. We write a symbol for the angle. The angle here, we call it theta. Circle with a line through it. So from this point of view, we saw that the 38 is your adjacent because it's your closest one. Your 27 is your opposite. Now you write the two letters O and A. Now we look at our trig ratio. Our trig ratio that we have here is TOA, O and A, so it's tan. So we write TOA. This tells us it's tan. So we write tan. We put the angle here, which is theta, is equal to opposite, 27, over adjacent, which is 38. We want theta, so we apply the inverse. So it becomes tan inverse, parentheses, 27 divided by 38. Now we can plug this into the calculator. So on decimals, to find the inverses, you have to hit function, FUNC, type in tan inverse, type in 27 divided by 38. You get the value 35.39. So you can say theta is roughly 35.4 degrees. Okay, give me a second. I can pull it up for you. I can show you the notes that I had this for. It was finding an angle. Okay, when we find an angle right here, we use our inverse sine. Okay, are inverses. We set up the inverse trig ratio to solve, find, or get any angle of a right triangle. Let's look at B. The angle here is at the question mark, so we draw the person here. The symbol for the question mark that we use, it's a missing angle, so we put the theta symbol. From this point of view, we can label the pieces. 10 is your farthest side, so this is your opposite. 39 is your diagonal, so this is called your hypotenuse. The two letters that you have is O and H. Now we take a look at our notes. We saw that O and H is sine, so this is S. So we can say sine of theta is equal to opposite, which is 10, divided by your hypotenuse, which is 39. We're trying to get theta alone, so we do theta is equal to the sine inverse of 10 divided by 39. We go to decimals. Tan inverse is right here. We do tan inverse of 10 divided by 39. You get 14.85. So theta is roughly around the value of 14.9 degrees. Let's look at C. We draw the guy here at the question mark. The question mark here is a missing angle, so we put theta here. Theta represents a missing angle measurement. From this point of view, 11 is your adjacent, 27 is your hypotenuse. We have the letters A and H. Let's look at our trig ratio. A and H is cosine, CAH for ca. So we can write this cosine of theta is equal to adjacent, which is 11, divided by your hypotenuse, which is 27. We're trying to get theta, so we do our inverses. Theta is equal to cosine inverse 11 divided by 27. We grab a calculator. We put cosine inverse 11 divided by 27. So it's 65.95. So we can say theta is roughly 66? Yeah, 66 degrees, approximately, or about. Let's look at letter D. We draw the guy here. The question mark is our theta. .24 is our closest one. So is this adjacent? You're wrong. Let me show you. A lot of people think it is, but if I rotate this from that point of view, let me rotate it another way so you can see it. Right? So do you see how it's really what? The person's up here. So let me just flip the numbers really quick. So, right? So you can see it much better. Boom, there you go. So the 24 is actually your hypotenuse. Your 12 here is going to be your opposite. So you have O and H. Let's bring up our notes. O and H is opposite and hypotenuse, so that's your show sine. So I write sine here, S. So I write sine theta is equal to my opposite, which is 12, divided by my hypotenuse, which is 24. I want to get theta, so I do theta is equal to sine inverse 12 over 24. I can now plug this into decimals. Sine inverse 12 divided by 24, that gets me 30 exactly. So I can say theta is equal exactly to 30 degrees. This is one of our special right triangles. Let's look at E. We draw the person here. The question mark is theta. 13 is going to be our adjacent, and 20 is our hypotenuse because that's the longest side. We write the letters A for adjacent and H for hypotenuse. We look at our notes. A and H is for cosine, ca. CAH, so it's CAH, so I write cosine of theta is equal to adjacent, which is 13, divided by the hypotenuse, which is 20. Trying to get theta alone, so I do theta is equal to cosine inverse of 13 over 20. So now I go to decimals. I type in cosine inverse 13 divided by 20. I get 49.45, so that's roughly 49.5. Yeah. Theta is roughly 49.5. Is that correct? Let's just double check. 49.5. Good. And let's do letter F. We put the person here on the question mark. We know the question mark. We have a symbol for that. That is theta. Theta. Here, 51 is our adjacent. 68 is our opposite. So we write A and O. I don't have A and O. I have O and A. So it's just supposed to be O and A. So it's O and A. So then it's T, right? Let's take a look. O and A. Yep. O and A. TOA. So we write this as tan theta is equal to opposite, which is 68. Divide this by your adjacent, which is 51. Okay. We want theta alone, so theta is equal to tan inverse of 68 divided by 51. So what do you have? Tan inverse 68 divided by 51. Theta is approximately 53.1. Let me show you this in decimals. So tan inverse of 68 divided by 51, 53.1 degrees. Okay, so there you go. So just letting you know that when we did number 10, we were solving for the angle. So I can write here, when solving for an angle on a right triangle, we use the inverse trig. Okay, when solving for an angle on a right triangle, we use the inverse trig ratio. Right, this should give you a better understanding of what we did when solving for an angle on a right triangle. Yep, we can just say we saw we used the inverse trig ratio. Okay, so you should see all of that right here. Right, that was different than number 9, because for number 9 we used the regular trig ratio. The trig ratio is used to find the missing side. The inverse trig ratio is used to find the angle. All right, there you go. That is all page 3.